Hello, Science 20s. Our lesson today is going to be on position time and velocity time graphs. We're going to analyze them and be able to, when looking at these graphs, figure out the displacement, the velocity, and the acceleration in each situation. So let's take this position time graph. And what we're going to do is we're going to take these points from here. And what I would like us to do is plot these points on the graph. So we have at time of 0 seconds, we have a position of 0 meters. At a time of 1 second, we have 1 meter. 2 seconds, 2 meter. 3 seconds, 3 meter. And we'll notice that there's a pattern as we go through this and go up. If we connect those dots, you can see that as time increases, so does the position that we are moving. Well, the rule that we have to understand when doing this is calculating the slope of a position time graph equals the velocity of that position time graph. And so here we'll just clear this screen because that was a different example before. So what we're going to do is we are looking at rise on the y-axis over run on the x-axis. Now, this should make sense because if we are truly finding slope, and slope on a position time graph is velocity, so these guys are equal to each other. On a position time graph, slope is the same as velocity. Remember the formula for velocity. Velocity is the change in position over the change in time. So my slope, my rise is going to be my change in position. My run across the x-axis is going to be my change in time. And remember this, because that's going to equal my slope, that's going to be what my velocity is. The formula makes sense. Rise over run, position over time. So let's substitute this in and find my slope in this example. So we'll put the red line joining the two so it's easier for us to see. So my rise, and it's always the second dot minus the first dot for y. So here's my second dot. So my rise is 10 meters minus 1 meter. So this is going to be 10 meters minus 1 meter. My run, or my change in time, is going to be 10 seconds minus 1 second. So 10 meters minus 1 meter is positive 9 meters. 10 seconds minus 1 second is 9 seconds. And now we take our calculator and we go positive 9 divided by 9. My slope is positive 1 meters per second, which means that is my velocity in this example, because on a position time graph, slope equals velocity. And so this is a huge rule you need to know. Okay, well, let's do this. Let's try another example. So we have a new position time graph. Again, I always like to check the axes. Time is in seconds, position is in meters. Looks like we're going by 1, 2, 3 every 1 meter, 1, 2, 3 every 1 second. Perfect. So again, we're going to calculate slope. Slope is rise over run. So my rise is going up here. So we're going all the way to 12 meters minus my first one was we started at 0, so that's 0 meters. My run along that x-axis is I'm going all the way up to 8 seconds. And I started at 0 seconds. So 12 meters minus 0 meters is still going to be positive 12 meters. 8 seconds minus 0 seconds is still going to be 8 seconds. So positive 12 divided by 8 is going to be positive 1.5 meters per second. And again, this is a velocity because velocity is the slope on a position time graph. Well, let's look at a little harder example. So we're going to clear this. And we'll do an example here that comes with a picture. We're going to try to understand our picture. Now, the first thing we should probably do is, looking at our dots, we should figure out the location of these, but that means we have to also figure out by what are our bars going by. So if this is 200, let's go 50 minus 100 minus 200 minus, nope, that doesn't work. So I bet it's going by 40s. So this is minus 40. This is minus 80, minus 120, minus 160, minus 200. Beautiful. So we're going by 40s. So in order for us to calculate velocity, again, we're trying to find slope. They are equal to each other. So we're doing rise over run. So my rise is, well, this time, right, I'm going down. So my second one is actually this guy here. So this was 400. And so this would be, we said it's by 40. So this is 440. This is minus 480. So we're going to have minus 480 centimeters minus, right, because we're always subtracting. So minus 480 centimeters minus a negative 160 centimeters divided by my run. Well, if that's 10, 2, 4, 6, yep, we're going by twos. So this is a 6, and this is 20, 22, 24. This is also 26. So we are going from 26 seconds, subtract, and we're coming down. This is 6 seconds. So negative 480 minus a negative 160 is negative 320 centimeters divided by 20 seconds. And my velocity is going to be negative 16 centimeters per second. I want to remind us that this negative is just telling us that we are moving, if we look at the graph, left. So we could also say 16 centimeters per second left, for it looks like this is some sort of bulldozer. Now, that was for position time graphs. If we take a look, this is not a position time graph. This is a velocity time graph. And there's a different rule for that. In a velocity time graph, when we calculate slope, slope will tell us the acceleration of our vehicle or whatever else we're doing. So position time graph, slope tells us the velocity. In a velocity time graph, slope tells us the acceleration. So again, it's still going to be rise over run. But this time, let's take a look at what my rise is. Rise is my change in velocity. My run across the bottom is still my change in time. Now, this should make sense because when I have my change in velocity over change in time, that is the definition we've been using for acceleration. So again, our number should make sense. So again, let's look at our slope and let's calculate it. So rise, my rise is going from 0. So this is 4 meters per second minus 0 meters per second. My time is at 10 seconds, up from 0 seconds. So this is 10 seconds minus 0 seconds. So 4 meters per second minus 0 meters per second is still a positive 4 meters per second. 10 seconds minus 0 is still 10 seconds. So when I'm all done, I will get an answer of positive 0.4 meters per second squared. Remember, this is an acceleration. So we are accelerating forward at 0.4 meters per second squared. What we'll do is we'll try another one. So checking this out, let's check to make sure we know our value. So this is at 60 seconds. This one's going to be at 150 seconds. We're at 30 meters per second and 0. So in order to do this, we're going to find slope. Slope is still rise over run. And since we're finding acceleration, that means change in velocity over change in time. So my change in velocity, this one looks like it's at 30 meters per second. Minus down here, velocity is at 0 meters per second, so that's an easy one. My time is at 150 seconds, and my initial time was at 60 seconds. So 30 meters per second minus 0 is going to still be our positive 30 meters per second. 150 seconds minus 60 seconds is still going to be 90 seconds. So positive 30 divided by 90, we're going to have positive 0.3 repeating meters per second squared. Remember, this is an acceleration because in a velocity time graph, the slope is the acceleration. Now, there's one last thing. So velocity time graph, the slope was the velocity. In a position time graph, the slope was the velocity. In a velocity time graph, the slope was the acceleration. In a velocity time graph, the area underneath the line equals the displacement. So if I take a look here, right, here is my 0. So this is the area underneath this line. So all of this is the area. So in order to find the displacement, we are going to take length times width. So we have positive 6 meters per second. And we are going to multiply by 10 seconds. So in this example, my displacement is positive 60 meters. I am forward 60 meters from where I started. So this is our third clue. Let's clear this. Let's try another example. So first off, if we take a look here, we started here at 14 centimeters per second, our velocity, and we finished over here at 14 centimeters per second, meaning we are going at the same velocity all the time. For all 7 seconds, we are traveling at the same velocity. We are moving uniformly. So what is this vehicle doing? It is moving at uniform motion. And we know it's moving at uniform motion because the velocity, the speed is constant the whole time. Now the question is, how far did it move? So I want to find its displacement. Remember, to find displacement, we're finding area underneath the line. So here is my 0. And all of this, we need to find the area of. So my height, 10, 11, 12, 13, 14 centimeters per second. And my width is 5, 5.5, 6, 6.5, 7. So 7.0 seconds. So my displacement is 14 times 7.0. And that's going to get me positive 98 centimeters. I know it's positive because it's above the 0. Okay, let's try one more example. Okay, now this one's quite good. So we can see that here is my line. But again, my 0 is up here. So we say, hey, the area under the graph, but it's actually the area to the 0. So we are filling in all of this. So to find displacement, it's going to be length times width. So my length here at 0 to -10, -12, -14, -16 centimeters per second, 10, 20, 30 seconds. So -16 times 30. My displacement is going to be -480 centimeters. So I am back 480 centimeters from where I started. So we have three things that we have mastered today. First, when we have a position time graph and we calculate slope, the slope tells us the velocity. When we have a velocity time graph and we calculate slope, the slope tells us the acceleration. And lastly, on a velocity time graph, when you calculate the area under the line or above the line, depending on the type of example, that is when you figure out displacement. Hope that clears up some of your problems.